Hello, dear students. This is the numerical related to paper machine operation. So here we'll be talking about the calculations related with the press and dryer section of the paper machine. So basically, as you know, paper machine can be divided into three important sections: wire section, press section, and dryer section. So first of all, the water is being removed in the wire section, then press section, and then in the dryer sections. If you start from the head box, so head box is having the nearly consistency of 0.5 to 1%. That means it's maximum 1% is the solid, 99% is the water there. Then we are removing the water in the wire section and hence into the press section. We are having the dryness 20 to 22%. So it's a very important numerical, especially for the paper industry, for doing the calculation in press and dryer section. How much is the water removed? How much should be the capacity of the tank? How much should be the size of the pipelines for removal of the water? Again, the steam required in dryer section. How much steam is required? So all these things can be considered by doing the calculations. So these calculations are really very important for the engineers and technicians working in the paper machine section of the paper industry. See a simple numerical here. Explain the steps for calculation of removal of water amount in press and dryer section in different parts in an integrated paper mill handling 500 tons of oven dry copier paper per day, which is dried from 22% solid to 50% solid in press section using the mechanical force, and from 50% solid to 95% solid in dryer section using steam. Steam required is given here is 3.5 kg per kg of water evaporated. So calculate the steam requirement on daily basis and assume any other parameter if required. So you can see here basically you can start from quantity of the paper that's to be manufactured in the machine. So quantity is given. We are manufacturing 500 tons of paper. So normally industry is a final paper which is coming at the drum rail after completion of the drying. It's having the 5 to can say 2 or 3% of the moisture. But here for simplicity, we are assuming that 500 tons is the oven dry solid here as given in the numerical. Otherwise, we have to do the calculation and subtract the amount of the moisture present in the paper. But here we are taking 500 tons is the oven dry paper. That means no moisture is there. No water content is there. It's totally solid. So solid percentage can be calculated here. So solid percentage in inlet stream to press is given 22%. That means when the paper is entering to the press section, it is having 22% solid. As oven dry solid will remain same throughout the process, because during the pressing action, basically we are removing the water. So we are considering the solid is not being lost here. So solid loss is considered to be 0. Again, it's a nearby to 0 only in actual sense in the industry. If you see there, generally we are not losing any solid in the press section. So you can take the calculation here based on the oven dry solid as the basis here. So calculation for the press section, total mass at entry point to the press section will be equal to 100 upon 22 multiplied by 500 tons, because 22 is the amount of solid. So total will be 100 here, 100%. That's why we are taking 100 by 22 multiplied by the amount of solid is 500 tons. So it is coming 2272.727 tons. Then total mass at exit point to the press, it will be 100 upon 50 multiplied by 500 tons. It will be 1000 tons. Then see here, we will take the difference of these two. That means the entry point and exit point, and the difference of total mass is nothing but mass of the water that is being removed in the press section. So just by taking the difference of A and B, we can get the water removed in press section, and it will be equal to 2272.727 minus 1000. So it will be coming 1272.727 tons of water. That's coming here from the press section. So this is the first part, water removed in the press section. Now come to the dryer section here, calculation for dryer section, the total mass at the entry point to dryer. Again, we'll take the similar format here, 100 by 50, because 50 is the moisture percentage or dryness at the entry point to the dryer. So 50 will be the solid, then total mass is 100. So 100 by 50 multiplied by 500, it will give 1000 tons. Then we are taking the total mass at a heat point to dryer, so it's 100 by 95 multiplied by 500, so it will be coming 526.316 tons. Again, we'll take the difference of the total mass at the entry point and exit point, and that will give you the water removed in dryer section. So that will be 1000 minus 526.316. So this will be equal to 473.684 tons here. So all these calculations are taken to tons, that is on the daily basis, per day. So now come to the steam requirement. The steam, how much steam should be fed in the dryer section or should be given the dryer section for drying the paper on daily basis. So you can see here the steam requirement in the dryer section is already given in the numerical. The average is 3.5 kg per kg of water evaporated here. Per kg of the water evaporated. So this is given. Again, this depends on the quality of the paper. Normally for copier paper, this much will be the requirement of the steam. But for some grade of paper, like for the transformer paper or for condenser paper, this requirement may go even up to 5 or 6 kg per kg of the water evaporated. Right, so this will be equal to, now we are taking the 3.5 for per kg of water evaporated, and water evaporated is already calculated here. That is the water removed in dryer section. Dryer is removing based on the evaporation process only. So 473, this is the water evaporated. We'll take here, multiplied by the quantity of steam per kg of the water, 3.5. So 3.5 multiplied by 473.684, and this will be coming 1657.894 tons here. So in this way, we are calculating the steam requirement on daily basis. Based on this one, we can do the calculation on the hourly basis also, and we can determine how much steam should be blown in the different dryers basically. And again, depending on the number of dryers, you can find the flow rate in the dryers for steam requirement here. So normally we are using 35 or 50 dryers. Generally it's varying between the figure 35 to 50. So depending on the dryers, again, we are determining the production capacity. So for this numerical, this is the steam requirement. We have done the calculation. And the two part was the water that is being separated in press section and water separated in the dryer section. So in this way, you can do the material balance here and utilize in the different processes of the paper machine in paper industry. Okay, thank you.